We are looking now at how the biomatrix is organized in space, what the spatial organizing principles are. The first one is connectivity. We had the fisherman's net, and we showed already that all entity systems are connected to all other entity systems. Another important aspect is that each entity system is the center of the web. This is a very interesting statement, that I am the center of the universe, and so are you, and so is every other entity system, every country, every organization, even every cell in our body. It gives a completely different impression of how life is organized than if we are thinking in terms of hierarchies, as we often do, that there's a government telling me what to do, an organization telling me what to do. What it implies, if I'm the center of the web, is that I can connect to other entity systems and influence them directly or indirectly. So if I, the orange dot in the middle with the larger circle around, want to influence, for example, that entity system surrounded by a gray shape, then I have to align with other systems, those systems that are in between me and that other system, so that I can exert influence on that system. This is typically the stance of leadership, which means managing outward, taking along other stakeholders, aligning stakeholders, so that we can create a better operating environment for all of us and develop other systems better. It is also the stance of public-private sector partnerships, for example. So it is a very important concept, and it is also a very empowering concept. Being the center of the web means I am not the victim of other structures. If they are connected to me, I am connected to them. If my boss gives me a hard time, then I'm not the victim of the boss, but I have the possibility to influence the boss. Maybe not alone, maybe I have to take my colleagues along. So it is a very empowering worldview to see oneself as the center of the biomatrix. Let us now look at spatial organizing principles of activity systems. The first one is that activity systems form chains of activity systems, and that these chains are contained in an overarching activity system, typically a supply chain. In reverse order, we can also say every activity system has or consists of sub-activity systems. So here we have an activity system and it contains sub-activity systems. For example, if I have an activity system like baking a cake, then the sub-activity systems would be assembling ingredients, mixing them, baking them, etc. Those are the sub-activity systems of the overarching cake baking activity system. Now, the cake baking activity system in turn can be part of a larger nutrition system or providing food to the family system in our families. These sub-activity systems can be sequential. That means they follow one after each other. For example, I have to assemble the ingredients before I mix them. I have to mix them before I can bake them. So those are sequential phases or sub-activity systems of an activity system, and they can also be parallel. For example, we could, when we start assembling our ingredients, also start heating the oven. So while we are going through the various sequential activity systems, parallel to them, the oven is already heating up. All process redesign in an organization follow those principles. They are really an assembly of sequential and parallel sub-activity systems. Another principle is that of continuity and how activity systems continue. So activity systems link up with each other, as we have heard, and they link up with each other in the sense that the output of an activity system becomes an input to the next activity system, and the output of that activity system becomes again input to the next activity system. And this continuity involves tapping. In other words, the next activity system has to tap the output of the previous activity system. For example, the cake tin has to tap the dough as I mix it, and the oven has to take in, be able to accommodate the dough in the bowl. So if I have a too big cake tin, then the oven cannot tap. Likewise, if I'm teaching you biomatrix systems theory, then you have to tap it. You have to take it in, what I say. If you don't, then my output is not being tapped. It has been in vain. Interesting enough, responsibility shifts in tapping. What that means is that I, as a teacher, have to ensure that I'm teaching my subject in such a way that you are able to tap it, to learn it. I have to make it as easy as possible. I have to make relevant examples for you, etc. But the taking in, the learning, is your responsibility, not my responsibility. If you want to learn or not, that is up to you. Having said that, obviously one can mediate tapping. If you were to sit face to face, then as a good teacher, I would look at you and observe you, and when I see that your eyes are glassing over, that you're looking away, that you get restless, I realize something in the teaching is wrong. Either you don't understand or I overload you, and I can try to mediate, explain again, ask what is the matter, give another example, etc. Through that tapping and the continuity of outputs into inputs, activity systems are forming what we call supply chains. Now, what is the difference between a supply chain and a value chain? A supply chain merely means that the output of my system becomes an input in the next system. Value chain means that every activity system along the chain adds value. If there's one activity system that does not add value, for example, shuffling papers around in an organization without processing anything, then this activity of shuffling the paper does not add value. So when we are doing process design in an organization, we make sure that every sequential and parallel activity system produces output that is value add to the input that it consumed from the previous activity system. We can look at the biomatrix as a web of interacting supply chains. In fact, when we are looking at the ecology, what makes ecological systems so exquisitely balanced is that the output of every activity system is used as input somewhere in the web of life. There is no waste, no superfluous activity. So if we're looking at the biomatrix from that point of view, then we can detect vertical supply chains and horizontal supply chains that interact with each other. Let us look at a vertical supply chain. A very famous one is the nutrition chain in the web of life. It is one of the main and very important supply chains. It starts with the planet. In fact, it starts with the sun, which brings light to the planet, and then continues through society down to the atomic and subatomic level of every individual organism or entity system on the planet. There are different sub-activity systems that we can observe. For example, at the planetary level, we grow food. At the societal level, we produce food. At the family level, we prepare food. Then we eat the food as individuals. It gets digested, metabolized, and eventually absorbed as nutrients. The different outputs after every phase are in growing food. We grow plants and animals. Those are being produced into food stuff, which we prepare into a meal, which we eat, and then it gets digested and becomes nutrients that are being absorbed. Now, in an activity systems chain, if output doesn't continue as input in the next activity system, we are going to have problems. If we cut a supply chain anywhere, then the entity systems following in the supply chain are negatively affected. For example, if we don't grow food on the land we have got, because there's a drought, then the societies and different families affected will starve. Or we could have enough food production, but there are poor individuals who cannot buy the food, so they will be negatively affected. Or as an individual, I could eat food, but I have maybe a stomach cancer and cannot digest the food, or I have a metabolic disease and can't metabolize. So the food doesn't get absorbed, and the cells are not being nourished, and my organism dies. Now let us look at horizontal supply chain. For example, on the level of society, we have the producing food supply chain that could consist of activity systems like we plant, we harvest, we mill and process the outputs of the harvest, and then we distribute that. And then it carries on at the family level, where we provide the food, we buy the food stuff, we store it, we cook it, and then we serve it, and so on. So the vertical and horizontal supply chains within the biomatrix interact with each other, continue along and across levels to form that web of interacting supply chains. And one of the important aspects that we normally forget when we design activity systems in the psychosociosphere is to look how do they continue and interface with the web of nature, for example. And because we are not looking sufficiently at that and not managing the interface within the biomatrix properly, we create problems such as, for example, climate change. Let us now look at another organizing principle of activity systems, namely that activity systems are multidimensional. So if we have one of those activity systems within the organizational matrix, for example, they are interfacing with all the other activity systems. And as a result, there is an intertwining with other activity systems that is happening. And that intertwining we have also discussed previously in the context of the biomatrix subwebs, that the systems of nature, of the psychosociosphere and of the technosphere are interacting. So they are intertwining. And because of that intertwining of those systems, the activity system becomes multidimensional. They leave residuous information or products and services within the activity system that makes the activity system multidimensional. Let me give you an example. If you're looking at our e-learning situation, it has all the dimensions of all the systems of the psychosociosphere present. So, for example, it has a psychological dimension. You and I, as we are engaging in an e-learning program, have psychological situations present. We are having cognitive, emotional reactions to the e-learning. We have also anticipated cognitive and emotional situations and built them into the e-learning program as best we can. There are also cultural dimensions present. Culture normally refers to ethics, aesthetics, science. So obviously there's lots of scientific stuff happening in e-learning. We also considered aesthetics. We try and animate as much as possible to engage the more aesthetic appreciation of our customers. There's an ethical dimension. We try to be neutral in terms of certain ideologies, or we try to be honest, transparent, etc. There's an economic dimension. It costs something to produce the program. It costs something for you to access the program. There's a political dimension involved that includes regulation. The particular e-learning technology allows us only to do certain things and not others. For example, it does not allow direct interaction the way we have set up the program. So this is part of the political dimension. If we had a face-to-face interaction, we would interact completely different, and I wouldn't lecture. We would have much more interaction and much more talk. Then there's a technological dimension. There are lots of gadgets involved in producing the e-learning and for you to access the e-learning. There's an ecological dimension. We are having a particular atmosphere around us, air, etc. Then e-learning travels across the space from you to me and from me to you. There is physiological dimension. I hope you are sitting comfortably and your body is relaxed. There may be a biological dimension. If you happen to munch some chocolate, you will feel very good as you are watching the program, so your brain chemistry will be favorably disposed towards e-learning, I should think. And there is a physical dimension present, the atomic, subatomic level, anorganic chemistry. What is the relevance of what I have said? Well, the relevance is that whenever we analyze a system, be it an activity system, an entity system, or even a situation or a problem, it is useful to go through these dimensions as a checklist and ask if some of those dimensions are, for example, producing cofactors to the way our activity system functions or our organization functions, or are cofactors to our problem. So likewise, when we design a system, we try to bring these different dimensions into the design to make a multifunctional design. As soon as any system incorporates more than one dimension, it becomes much more developed. So to improve development, we are looking at all those dimensions and consider our system from all those dimensions.